Ixia, a leader in performance analysis solutions, presents the IX Network video tutorial series. IX Network is Ixia's flagship software application for testing the network infrastructure, including all devices like routers, switches, network access controllers, broadband access, carrier Ethernet, and data center Ethernet. It's used by professionals around the world, including development and system test engineers, network design and support engineers, and even marketing and sales to demonstrate product capabilities and performance. This video tutorial is brought to you by the IX Network Product Management Team.
In this IX Network video tutorial, we are covering the Quick Flow Groups feature. The Quick Flow Groups feature is designed to quickly and easily create Layer 2 and Layer 3 traffic with just a few clicks. It has IX Explorer-like functionality and a user-friendly interface that can create the simplest to the most complex test packets for functional testing. To show you all the features of the Quick Flow Groups, we have broken up this video into 4 short chapters. Each chapter is designed not only for specific test cases, but also to highlight all of the features available in the Quick Flow Groups feature. Chapter 1 will cover the Layer 2 and Layer 3 test topology used in the demonstration. Chapter 2 will cover the Layer 2 test case. This includes creating and configuring the Quick Flow Groups, sending the traffic, and viewing the statistics and statistics options. Chapter 3 will cover the Layer 3 test case, which will include the use of ARP. And Chapter 4 adds a UDP header to the existing Layer 3 test case and shows you the various ways to do this, including using the Quick Flow Group grid, using the Quick Flow Group packet builder, as well as using user-defined fields. The first test topology used to demonstrate the Quick Flow Groups feature is a Layer 2 traffic test case. The objective of this test case is to verify that Layer 2 MAC traffic can pass through the DUT. Now this is a simple use case, but it will show you how to configure this type of traffic using Quick Flow Groups. The test setup consists of 3 Ixia ports as shown, and they're all connected to a device under test. Port 1 will send Layer 2 traffic into the DUT and it will be forwarded to port 2 and 3. And likewise, port 2 and 3 will send Layer 2 traffic that will be forwarded to port 1. So this is more or less a one-to-many test case. The second topology used to demonstrate Quick Flow Groups will be using Layer 3 traffic. The test case will be similar to Layer 2 in that there will be 3 Ixia test ports, and in this case we're sending IP traffic through the device under test, which will include showing you in Quick Flow Groups how to use ARP. In this particular test case, we'll just send unidirectional traffic from port 1 to port 2 and 3. That will cover what we call Chapter 3 of the video, and then in Chapter 4 of the video we're actually going to use the same test case topology and add UDP source and destination ports on top of the IP header, and we'll show you various ways to do that, including using UDFs. In Chapter 2 of this video, we're going to be covering the Layer 2 use case where I have 3 ports in the test, all doing Layer 2 MAC traffic. Port 1 will send traffic to 2 and 3, and port 2 and 3 will send traffic to 1. So all I've done so far is reserve my ports in the IX Network GUI, and the link is up. From there I can go straight to traffic. I can quickly and easily set up traffic using the Quick Flow Groups, and for Layer 2 I don't have to do anything else in the GUI, but go to traffic, go to Quick Flow Groups, and then from here I can launch the Quick Flow Group wizard, if you will, although it's only one screen, to add Quick Flow Groups. I can click it from here, I can click it up here, or I can click right here in the middle of the screen. So let's just do that. And it says, well, how many Quick Flow Groups do I want to create per port? For now, let's just create one on port 1 so I can demonstrate how to do that, and then we'll create the others. Okay, so there it is. So as you can see, this is basically the entire Quick Flow Group setup page. The top section we'll go over, and then the bottom section is the Quick Flow Groups I've just created. So you can see I just created one on port 1. My transmit port is port 1. My receive port I need to select. And for unicast traffic, the Quick Flow Groups is basically designed for one-to-one port mapping. So while I can select multiple ports here, that is only designed for multicast. For unicast, it's a one-to-one port mapping. Okay, now that I got transmit from to port 2, and I'm going to do Ethernet traffic. So one way to create Ethernet traffic is just to simply click down here, and it'll show you a stack diagram and just says, create your source and destination MAC. So I'm going to configure my destination MAC as 22, and my source MAC as 11. Just something quick and easy. Okay, and with that, basically done. I mean, I can apply the traffic and just start sending traffic. Now notice I don't have ingress tracking turned on, so I've applied it, and I'm gonna start it. And now that it's started, I'm gonna switch over to statistics. And the first thing you'll notice is that just like in IX Explorer, when I create a stream and I send traffic, I get stats on a per port basis. So as you can see, a typical layer 2, when I'm sending from one port, I'm actually receiving on both other ports because the traffic is being flooded because there hasn't been any learning frames sent from the other side. So let's go back and configure the rest of it. But again, to quickly create traffic, it's very simple. Okay, back in the configuration, I'm going to stop the traffic. And that will highlight my quick flow group again, so that means I can edit it. So now let's go ahead and add the other traffic patterns. Again, I need to go from 1 to 3 also, and then from 2 to 1 and from 3 to 1. So I could just manually add more quick flow groups by clicking on the quick flow group option here and adding some more. That's one way to do it. So let's just go ahead and do that. I want to add one for all 3 ports. Okay, so now they're done. And I could just actually continue to click. First of all, let me get my RX ports set up here. So I want to go from 1 to 3 also. From 2 to 1. And from 3 to 1. Okay, so once I've done that, now I can continue to click into encapsulation here and fill out the source destination MAC. But what might even be easier is to have a grid and just be able to do a same and fill increment. So what the quick flow groups offers is the ability to right mouse click on the column header and say column chooser. And from there I'm going to layer 2, Ethernet. And I can select source and destination MAC, add them in as to being a column. I actually want destination MAC at the bottom, and I want to move both of them up right after encapsulation. Okay, so you can see I have the ability to make these what we call griddable items. So the source and destination MAC can be in the grid as opposed to using the drop-down. So let's configure the rest of these accordingly. I can click on this one, the top level, and say increment by, and since this is a hexadecimal field, I'm going to increment by 17, which would make it 11 through 44. Actually, since this is also port 1, I want to make this one 12 just to make it simpler. 22 and 33. And then over here I could use the fill increment if it's straightforward. Otherwise I'll just type it in. 33. 11 and 12. So again, that's an easier way probably to configure your MAC addresses. And of course, I don't have to just do one. I can do multiples. I have a nice drop down here with an increment function, a decrement function, or a list if I wanted to. So that's also available on the drop down. And to make this a little simpler, I'm actually going to change the frame rate to a packet rate of 1000. I'm going to do a same there. Changes all of them. And I'm actually going to just make 1000, 2000, 3000, and 4000. Okay, now I think I'm ready to go. I can apply this traffic. And this time, actually, I'm going to actually enable ingress tracking. What this basically does is, I'll have to apply again. What this basically does is each of these quick flow groups is now its own stream, and it's tracked accordingly. So I'll have basically each quick flow group will be tracked independently. Now, no matter if I add more MAC addresses or not, I can only track each quick flow group as one item, one entity, one trackable item. So start the traffic and switch over to statistics. Okay, now I can see I have a lot more stats here, which is basically my per PGID, or I'm sorry, per quick flow group stats, per stream stats, if you will. And I can see my rates on the ports. I have, let's see, port 1 had 1000 and 2000. That's 3000 frames per second. Port 2 had 3000, and port 3 had 4000. So I can see my TX and RX rate. It's kind of hard to tell though which MAC is going to which one, or which quick flow group is going to which port. So first of all, I can click on traffic item statistics. And in this version, what that gives me is a cumulative total of all the quick flow groups. As you can see, I have 10,000 packets per second. That's 1,000 plus 2,000 plus 3,000 plus 4,000 is 10,000 packets per second for all the quick flow groups combined. Now, if I want to see individual quick flow group statistics, I can click on it. I should say right mouse click and say drill down per quick flow group. And now what I can see is not only the for all the quick flow group statistics here, not to mention the TX and RX frames, I showed you the rate, but also the latency, megabits per second, timestamps, and whatnot. And also per quick flow group. Now I can see my 1000 and 1000 on my quick flow group 1, my 2000, 3000, and 4000 on quick groups 2, 3, and 4, as well as all the same statistics, including min, max, and average latency. So as far as statistics go, that's what you get with quick flow groups. There's some other statistics you can look at as well, but for quick flow groups, you have your main aggregated one and your per quick flow group statistics. Now let's go back to the configuration and show you some of the features there. Okay, first of all, you'll notice that I can change the rate and the frame size on the fly. I don't have to stop traffic, and I can automatically change the rate and frame size of any quick flow group. I can pause a quick flow group, and then I can repause it or restart it. That's called a suspend or a pause. And to show you some of the rest of the features, let me stop the traffic. Another nice feature here on the quick flow group grid is the ability to group the quick flow groups in a way that's different than the standard just straight grid. If you click on the little icon here, one useful one is to group by TX port. So now I can see for every TX port how many flow groups I have, and I can easily see the sources, destinations, and all of the configuration options under each port. So that's kind of a nice way to group them. So I've shown you how when you enable ingress tracking, you get the aggregated stats and the per quick flow group stats. There's all of these statistics at the top apply to all of the quick flow groups. So it's an aggregate configuration for each and every quick flow group. Interleaved and sequential, two different transmit modes. You can see how they differ by just clicking on one, and the screen will change. Enable quick flow groups is to enable them all or disable them all. You can see when I disable them, I get the X over here, so they're all disabled. And then, of course, you have egress tracking, which is to be able to track on the receive side ports, and you can sort on different things. There's another video for QoS remarking that highlights all the features in egress tracking. That's the same features as available in the rest of IX Network. And then latency measurements as well can be turned on. I'm sorry, latency bins. We already get latency measurements per quick flow group. I can show you the grids. In the grid, you have lots of other options to the right. Do you want this whole flow group to have a bad CRC or not? The size of the preamble, again, as a drop down. What type of payload do you want? Different payloads. You can also customize your payload. And under continuous is the type of transmission, continuous, fixed, and burst. Instead of changing that in the grid, you can double click on each quick flow group and pull up an editor in this fashion. So a lot of these things I've already shown you in the grid. Here's your frame size, your payload, the suspend, which is the same as hitting that pause. You can pause the quick flow group, and there's the preamble and the transmission mode. In addition to that, you can also edit the packets via a full-blown packet editor. So I can, for example, right mouse click on Ethernet 2 and say append protocol, pick just about any layer 2 and layer 3 header you might want, and add that to the packet, and then further customize it by expanding it and editing each of the fields. And there'll be more on that later in the in Chapter 4 video. The Varieds Field preview screen will show you what the packet is going to look like going on the wire. So I've only opened up one quick flow group at a time here, so I only see the one. But as you increment MAC addresses or increment IP or increment UDP headers, you're going to see what the packets are going to look like on the wire from this screen here. So it's a nice screen to have. And more on this screen again in Chapter 4. Okay. Okay, so that's it for the layer 2 use case. Again, showed you how you can quickly just right after your reserved ports, click on traffic, add quick flow groups by clicking on the wizard button here, which is simply saying how many quick flow groups do you want to per port, and then simply adding your headers. You can modify them, create columns for them, as well as in the traffic you'll saw the aggregated statistics, which is kind of nice, including latency as well as the per quick flow group statistics. In Chapter 3, we're going to cover how to send layer 3 traffic, IP traffic, using quick flow groups. So the configuration is the same as the other use cases. Basically 3 ports connected to a device under test. The device under test has an IP interface on each port, and the Ixia ports will have the same. So after you've reserved your 3 ports, when doing layer 3 IP and ARPing is needed, we need to set up protocol interfaces to help resolve that ARP. So as you can see here, I've already set up 3 protocol interfaces, 222, 55, and 66 with a gateway of .1, and they have not ARPed yet. So if we're going to use quick flow groups for layer 3 IP, we need to ARP first. So we'll highlight them all, and actually we can just hit the button here. And you can see the ARP was successful and that link went away. Now when we go to traffic and quick flow groups, we're actually going to create 2 quick flow groups, because in this use case we're going to actually send traffic from port 1 to port 2 and from port 1 to port 3. So I pull this down and select 2. And for the second one, I select 3. So then we also have to change the manual MAC mode to ARP for both ports. And then we need to add our IP header, which you can go right in encapsulation, say I want IPv4, and then just configure the source and destination address. The source address is 222.1.1.2. And again, you can create a list, an increment, and a decrement. And destination on the first one is 55.1.1.2. And then using the copy down function, I can add that IP header, and then all I have to do is change the destination address to 66. Enable ingress tracking so I can see the results per quick flow group, and apply. And now that the apply is done, we can start traffic. Switch over to statistics. Click on our traffic item statistics to see the aggregation of all quick flow groups in the main traffic item. So this is both flow groups. We can look at the latency, the loss at a very high level, all the quick flow groups, however many you have. And then we can drill down per quick flow group and get detailed stats for each one. And we can see there's just a small frame delta. We can see our rate, latency, etc. And again, just like in layer 2, we can do a column chooser if we want to put our source and destination IP address or any other part of the IP header into the grid. The grid over here, we can just select it, source and destination, add it to the right, and then move them where we want them to be. And there they are. And of course, after we stop traffic, we can edit them from the grid or, of course, the drop down from here. So as far as layer 3 with IP, that's all there is to it. Again, for more details on the grid, the additional options, you can look at chapter 2. And of course, there's more on packet editor information in chapter 4. In chapter 4 of the Quick Flow Group video, we're going to cover adding a UDP header on top of the existing layer 3 IP demo that we did in chapter 3. So the first thing we want to do is add the UDP header. I've already taken away one of the quick flow groups for this demonstration. We can just use from port 1 to port 2. So there are really two ways to add a UDP header. Probably the quickest and easiest way is to simply pull the drop down for the encapsulation and hit the add next to IPv4, which will append a stack, and just select UDP or find whatever you want to add within this window, or click other protocol to see additional protocols to add. After selecting UDP, you'll see that we can change the source port and the destination port, which is what we want to do in this demonstration. But as you can see, there are also additional fields within the UDP header that are not shown here. So if this is all you need to change, great, you can do it right here. Otherwise, you can go into the packet editor, and let's do that now to see what additional things you can change there. Click on packets and expand the tree. Now this is our full-blown packet editor. We actually have a whole separate video on the packet editor, so if you need more information on that, you can please watch that video. For right now, we're just going to scroll down to UDP, and we'll see that yes, we have source and destination port as well as length and checksum, and you can do all the same operations for any field here, including add more headers, delete headers, etc. So in this case, we want to change the source and destination port. So let's edit this field and the destination field. And let's change the source port to an increment list of, let's say, starting with source port 1 to source port 3. And for destination port, let's just go to destination port 4 through 6. Now in this video, we're probably going to focus on more on the source port. So we'll see we have values 1 to 3. So we'll see the different ways you can change that, not just here, but also using what's called UDFs, or user-defined fields. So let's also note in this window that the offset for the UDP source port is 272 bits into the packet, and the length of the field is 2 bytes, which is 16 bits. So we'll need to note that for later on. It'll help us when we're doing egress tracking as well as the UDF. So hit OK there, and from there we can just apply. Make sure the apply is good. Okay, now let's set up egress tracking so that we can track those three different values for the UDP source port. So since we don't have any custom offset for that, we're going to need to go into a custom setting and use it was 272 bits in, and the length of the field was 16 bits. Now as you can see, this particular egress tracking window only tracks 12 bits, so what we can do here is go 280 bits in and just track the 8 bits, because we've only changed values 1, 2, and 3. So with that, we can apply again. And what we should see in the statistics is once we do the egress tracking, is we should see all 3 coming into port 2. So we'll start the traffic and switch over to the stat viewer. Let's click on the traffic item statistics to get the aggregate high level, and we see we're doing fine, 84,000 packets per second, TX and RX. Now let's drill down to our quick flow group, which there should be 1 with relatively the same statistics. And since we've turned on egress tracking, we can see on the RX port of this, as well as the TX, what was sent and received. So we can see at 280 bits in with an 8-bit field, we have 3 values coming in, 1, 2, and 3, and we can get some statistics for each of those. Okay, so that's one way to set your additional fields like UDP source and destination port, and then get tracking information on them. Let's look at a second way to do that. So now we're going to show you how to increment that field using UDFs. So the first thing you want to do is take the packet editor UDF, or the packet editor incrementing function, away, so we can do it via UDFs. One other note about the varying the fields here within the packet editor or within the grid is that you get a nice preview of the packets that are going to go on the wire. So you can see here our destination and source MAC, our source and destination IP, and our source and destination UDP port numbers. So anytime you're incrementing these within the packet builder or the grid, you're going to see the settings here. And then later on we'll see the UDF settings over here. So let's go back into packets, into UDP, and for source port, let's just make that the default. You cannot use an incrementer here as well as a UDF. Make that the default value, which should make it work. And then we're going to go over from the flow groups tab at the very bottom over to UDFs. Now with UDFs, just like in Explorer, there are 5 of them as well as a table UDF. And for those of you who are familiar with IX Explorer, this should be very familiar to you. The window may look a little different, but in actuality the fields are the same. So we have several different types here. You can do a range list, a value list, counter, which is the one we're going to do. We can have nested counters with inners and outer loops, and random, and IPv4. So let's go up to the counter, and the byte offset, just like in Explorer, the byte offset was 272, which was 34, but we can do 34 bytes in, but we can do 280, which is 35 bytes in. So let's do 35 bytes in. We'll make the width of the counter 8 bits, and we'll be able to basically track the same way. Now the nice thing about using UDFs that you cannot do in the packet editor is that you can go across boundaries. So in the packet editor you have very defined fields. You have the source port, the destination port, you have IP source, IP destination, and you can increment the fields within that, increment the values within that field. However, with a UDF you can go across fields, and that's something unique you get here, as well as some of the other different types of incrementing functions that are here and not in the packet editor or the grid. As well as there's ways to chain them just like in Explorer. Okay, so we said the width was 8 bits. The bit offset, we can leave that at 0. The starting value is 1. And let's do a count of, let's say, 5. And we'll just step by 1. So instead of doing 1 to 3, we're just going to do 1 to 5 and see how that looks. And we want to do an increment function. So we'll say OK there. We see our UDF there. We'll apply. We still have the egress tracking turned on, so we can see what it looks like as it comes through. Go back to statistics, traffic item, and at the high level, all the flow groups are doing well. We drill down to the flow group that we want. In this case, there's only one. And then we do our egress statistics off of that. And there's your 5. So again, that's another way to do incrementing. It's a user-defined field. And again, you can go cross packet boundaries, across the byte boundaries and bit boundaries. Okay, I'm going to stop that, come back into configuration, and now I want to show you how the UDF is showing in the packet view. So double click on the quick flow group, go back to varied fields, and now we can see not only the UDP source port has a default, because the default is now up here, basically value offset length 8, and you can see 1, 2, 3, 4, 5, and then the destination port, which had 3 values, is continuing to increment in a value of 5 as well. So you can see how the UDF and the regular incrementing, decrementing list functions in the packet builder are incrementing. Show you one more feature. Besides the 5 UDFs here, which is a nice way, just like in Explorer, we also have the table mode UDF. Now the table mode UDF is also like in Explorer. You enable it. You can add a column, maybe call it TCP, or else, I'm sorry, UDP source, and you can configure your own. The offset was 35, the length was 2, and the format, we'll just put in decimal, and we'll say OK. And then we can type in a value of 1, 2, 3, etc. Add another column, call it UDP destination, which is at 288 bytes, which is 36. It's also a 2-byte field, and it's we'll just say decimal. Oh yeah, I'm sorry, I'm off by 1, I think. I'll just say 37 there. Anyways, you can see how you can increment multiple fields at the same time and in any values you want. I could do this backwards if I wanted to. So the table mode UDF is just like in Explorer, and it's a great way to truly increment multiple things at the same time any way you want. You can import values to a CSV spreadsheet, or I should say export and re-import them if you like, so you can create truly a unique capability. Okay, so that's it for this video. This video we've shown you the ability to add the UDP header, increment and decrement UDP source and destination ports, as well as track them using egress tracking.
For more information on IX Network, check out www.ixiacom.com. Thank you for your time and interest from the IX Network Product Management Team.